おはようございます。あれ、始まってるかなこれ。今日の朝のHoudini作業配信を始めていきたいと思います。今日はエンタグマさんの作例で面白そうなのがあったのでやってみようと思います。ちょっと今日のは事前に軽く見たんですが、なかなか難しそうでした。はい、では始めていきます。
Finds edges with a high curvature in a given paneling. Recently I was working on a procedural paneling setup, and while trying to build something that finds edges with a high curvature in a given geometry, I came up with this setup as a byproduct, and I quite like it because it looks organic, sculptural in a way, but a bit abstract-ish. And also the setup involves surprisingly little vex. We won't get around it completely, but it's absolutely manageable. So, in Houdini as always, let's start by dropping.
解像度が低いな。はい、バージョンは19の最新です。
Dropping down a GeoNode, diving in there, and then using a file node to load up a file. In this case, I downloaded a 3D scan of the statue of an...
なんか少々ありなんだろう。あれ間違えた。なんかおかしいぞ。あ、入ってんのか、ジオメトリー。大丈夫か。ちょっと重いな、さすがに。これは無理かな。今試しに Discord の作業配信をやっているんですが、ちょっと今日からやってみようと思って、ただこれちょっと重いすぎるな。無理か。ちょっとこれ重いな。無理くさいな。いけるか。これ厳しそうな雰囲気するな。いけないかな。迷うとこだな。これはちょっと厳しいか、さすがに。やっぱ反応悪すぎるもんな。じゃあ、これで何触るかって言った OBS と、まあちょっとやるだけやってみるか。ちょっとお待ちください。ちょっと配信しておくか。 ちょっとやるだけやってみるか。はい、すいません。
Napoleon from 3dscans.com, and I'll just point Houdini to that respective file. Let's uncheck show sequences.
やるだけやってみようと思います。ないのか。これは事前に落としてあったやつですね。3dscan.com にあるおなじみの。
There's one entry just to make sure, and let's select this Napoleon STL and hit accept. So after a few seconds of loading time, we can see that this Napoleon statue came in the wrong way around, and when we click on the info icon here, we can see it's got a size of 1.8 times 3.5 times 1.8. So let's first orient, recenter, and resize the statue here by first using a match size, which we'll set to scale this thing to fit. So now it's centered, and when we hit info again, has a maximum size of 1, like this here. And also we can see that the polygons here are reversed, so
動きが遅すぎてこれきついな。いける気がしねえな。
let's just reverse them back using a reverse node. So now the normals point in the right directions, and then let's just use a transform set to rotate 180 degrees around Y and 180 degrees around Z to get Napoleon upright, like this here. Next, depending on your preferences, you might want to make this bust symmetrical. You can do so if you have Side Effects Labs tools installed by using the Labs Symmetrize. Just set it up to make the mirror direction along the X and not the Y axis, like this. And now you can see we've got a symmetric Napoleon.
動きがめっちゃ遅いな。
If we like that. I'll just leave it here and work on the normal unsymmetric bust here. And just to make sure that this thing is closed and doesn't have holes, I'll just briefly want to turn it into a VDB and then mesh it back again. So using a VDB from polygons, dropping that down and scaling down that voxel size quite drastically to 0.005. So we're getting a bit more high resolution.
これ絶対無理だろ。0.005だと。これでポリゴンに戻してリメッシュするんだよね、きっと。いけんのかな。いけるか。で、コンパクトで。
in here, and then using the convert VDV node, we convert it back to a polygon like this. Lost a bit of detail, so I could increase the voxel size here to my liking. In this case, this is fine for me. This works well. Next, you can see this mesh now has these typical meshing artifacts when you're converting from a volume to a polygon, and instead I want to have a rather isotropic triangular grid using the remesh node. I can turn this into what I want by setting up my remesh node to a target size of the same size as my voxel size here. So in my VDB from polygons, I'll just right click in the voxel size, go to copy parameter, and then in the remesh under the target size here, I'll just paste as a relative reference. And now remeshing takes a bit of time, but after waiting for a few seconds, we can see we now have this triangular mesh, which is exactly what we wanted. Next, just for good measure, we're going to add point normals here. So using a normal node that we're going to set to points, and then let's find out what the curvature of this mesh is and in which areas the curvature is high. I'm going to do that using a measure node, and I make sure that I've got the tool handle selected here, so my visualization
これビジュアライズされないけど。
measure node, and I make sure
そういうことか。なんかおかしいな。ちょっと待って。そういうこと、何これ。どういうこと？こっちか。
that I've got the tool handle selected here, so my visualization for what the measure node actually measures is showing up. In this case, I want to run the measure node over points, and I want to measure the curvature. And you can now see that areas with a high curvature show up in red, and areas with a low curvature show up in blue. But not only do I want to calculate the curvature, but I also want to calculate the direction in which the curvature changes, which I can do by appending another measure node. And when middle mousing on the first measure node and clicking the info window here, we can see we stored an attribute called curvature, which is what we are visualizing up here in this node. And then down here in this node, I want to set this to work on the direction in which the curvature changes, which I can do by appending another measure node. And when middle mousing on the first measure node and clicking the info window,
アドルベートで作られてて、極率が高い方が赤目で、カルチャーアドルベートを
here we can see we stored an attribute called curvature, which is what we are visualizing up here in this node. And then down here in this node, I want to set this to work on points as well.
カルチャーの極率が高いところ
Well, and I want to measure the gradient, which is me exactly what I want, namely the direction in which a value changes. I want to measure
これは勾配か。急なところが赤。
the gradient of the curvature that I wrote up out here. So let's set this to curvature like this. You can already see
極率が高くて勾配が強いところを抽出しようとしている。なるほど。これ常に選択されてないとできねえのが厄介だ。なんかビジュアライズできないのか。状態じゃないとビジュアライズされないの見づらいな。
see those arrows appearing here, and they point towards the areas where the curvature gets higher. And in the next step, I want to use those vectors here to move points over the surface of this statue, of this 3D scan. However, if I had points along this curved edge here, they would only be moved in this direction here in a zigzag pattern, sometimes up, sometimes down. And I want them to be perpendicular to the direction of those individual points here, of those individual vectors, which I can do by using 2 lines of vex, which you could also compress into 1 line of vex. What I want to do here is take the normal, the point normal, and calculate the cross product between this point normal and a normalized gradient here. Normalized means that the vector of the gradient will be scaled, so it has a length of 1. And by calculating the cross product between those 2 vectors, I will effectively rotate the gradient so it sits perpendicular to its original direction and to the normal. Let me show you what I mean by just unchecking the normal here and dropping down a point triangle. And in here, I want to calculate a new vector, which I'm going to call dir for direction, like this, and it should be equal to the cross product of our normal, which is already normalized, so it has a length of 1, and the normalized version, so we're making sure we are also scaling the gradient vectors so that they have a length of 1, so normalize the gradient. on that respective point. And then let's just write this out onto our points, like so. Now let's visualize it by going to the Info tab again and clicking here on the direction, and we can see we are getting this colorful visualization, which is definitely not.
さっきの勾配とノーマルのクロスを取って突っ込むと。はい。これをビジュアライズする。はいはい。どんな色分布だよ、これ。
Clicking here on the direction, and we can see we are getting this colorful visualization, which is definitely not what we want. So let's right click on our visualizers here and edit our direction visualizer to be a marker and a vector marker. Quite long those vectors, so let's scale them down so they become a bit smaller. And also let's show some arrow tips. And you can see that now those vectors, they just point along the edge and not perpendicular to it, just what we wanted. And if this is a bit too chaotic for our liking, which it currently isn't to me, we could either, before we're calculating the gradient here or after we calculate the direction here, we could blur that attribute either by adding an attribute blur in here between the first and the second.
このアトリビュートグラフ。普通がじゃないか。オーバーチャーのアトリビュートグラフかけて、
measure node, and then making sure we uncheck pin border points, and we want to blur the curvature in this case. So now with increased blurring iterations, you can see we are smoothing out those vectors that we're generating here. Or let's just disable this for now, bypass it. We could also go down here and use an attribute blur here, in which we're going to blur out the directional vector, and also making sure we uncheck pin border points. And again, in the same manner, we can blur out those individual vectors here. We would have to make sure that we normalize them again so they don't lose their magnitude. I'll bypass this for now as well, because I just want to work with this raw data here. And now I want to create some points on this surface, which I will then advect using those vectors so that they draw lines on this surface. For that, I'll be using my curvature that I calculated up here, and I only want to scatter points in those areas where we have a really high curvature. And for that, first thing I'm going to do is use an attribute remap, which I'll attach to the measure node here. And I want to remap the curvature to another attribute, which I'm going to call density. Let's also visualize the density attribute by just clicking on it like this, and you can see
に入ってて、これはじゃあマックスが 2.8。
already, that's working. However, my curvature attribute is not necessarily in the value range between 0 and 1, which is what I want. Actually, the measure node visualizes here, so it's between 0 and 2.8. And to remap that, I could either manually enter 2.8 here, or I could just click compute range, which looks up the exact values that the incoming values have from the curvature. And now I want to remap them in a range between 0 and 1. Keep in mind that you have to re-click this compute range and re-enter the value to remap this incoming value between 0 and 1 each time you're changing the geometry that you're loading in this setup. So a more automated way to do that would be to use an attrib promote, pipe in our measure node in here, and we want to promote our curvature to a detail attribute, so taking all these individual point values and just calculating one single value out of it, and we want to know the maximum of it. And then we don't want to delete the original, but we want to change the attribute's new name, so let's call this one just max val, and also let's copy and paste this node down here.
ディテールに値を最小と最大を移すのか。
Write up like this and change this to minimum and call this one minval. So now, if I highlight this and look at my geo spreadsheet here into the detail attributes here, you can see.
デリートオリジンつけてるからかもしかして。そっか。カンバチャが消えちゃって次のやつ引き継がれねえのか。で、ミントマックスが入って、
I'll highlight this and look at my geo spreadsheet here into the detail attributes here. You can see I've got my max and minimum value of my curvature automatically written in here. Now what I can do is look up the max and min values in my attrib remap down here by just accessing them with a short expression. So let's look up the detail attribute from our attrib promote 2, which is called minval.
はい。インデックスか。こっちはゼロかな。で、これをして、マックス。これで
And we want to
プロシージャ
look
ー
up
がある
the
のか。
first component like this, so that should evaluate to 0, which it does. Let's copy this whole expression, click down here and paste it in here as well. However, in this case, we want to look up the max and not the min val, so that also worked. All right, so now we automatically have those values changed no matter what the input geometry without having to click compute range. Right, let's visualize the attrib remap, and down here I can influence Right, let's visualize the attrib remap.
色つかねえんだけど。 シティか。
Into geometry without having to click compute range. Right, let's visualize the outer remap, and down here I can influence how these values are being remapped using this ramp here. And what I want to set up is a rather tight ramp, something like maybe this, and also dial this back a bit. So we're having a really high contrast area here, and only those really strong edges having a value. Different than 0. And now what I can do is use a scatter node, check the density attribute here, and we can see that now we are only scattering points in those areas with a high curvature. In this case, I'm gonna scatter 2000 points here, and let's just scroll down here. I need only one relaxation iteration. For now, that worked fine. All right, now we have points here, and we want to move them using the vectors here in this stream. I'm going to do that using a solver, so each frame I want to move those points a bit further, with the points going in the first and the vectors going in the second slot here. So in the solver, I'll just drop down a switch first, and in here here I'll wire in the previous and the input 1, and with a brief expression $ff equals to 1, I make sure that this switch only on the first frame uses the input 1 directly, and then on the consecutive frames switches to the data coming in from the previous frames. It's not absolutely 100% necessary to do that. It's just being polite, nice, and working somewhat cleanly. After that, I'll just drop down a point triangle, and in here we're going to write 6 lines of VEX code. What I want to do in here is first I want to find the closest point on this surface here. Coming in here, let's just disable the visualizer. So for each of those points that we have here, I want to find its closest point on the surface, its closest position on the surface. So my surface coming in through the input 2 just goes into the second slot of that point triangle in here. And the first thing I want to look up is the nearest point to my current point's position. So that should be the near point on my surface coming in from the second input slot, i.e. 1, at our current point's position, like this. Next, from this point that we just found, the nearest point, we'll look up the directional vector. Let's call this one dir again for direction, and use the point function to look it up. So we're going to look up from the surface an attribute called dir, and we want to look it up from the point that we stored into the npt point number. Now let's just for good measure make sure that the direction is normalized to have a length of 1. Just using the normalize function to normalize the direction and write it back into its original variable. Then let's create an amplitude slider. Let's call this one amp. And call this one, I don't know, advection strength underscore strength, like this, and then click on this icon here, and Houdini automatically creates the slider, allowing you to dial in our case, a rather small value for the advection strength. I had good results with 0.005. Okay, all this preparation only to be able to advect those points. That means moving those individual points. So I'll take my current point position and add to it the direction times our amplitude. And now maybe we move this point away from the surface. So what I'll do next is reproject it onto the surface just by looking up the nearest position on the surface, not necessarily its points, but just the surface position, and then moving that point there. So be at P equals to min pos, which is giving me the nearest position on a surface towards any other position I feed in. The surface I want to look up is the surface coming in through our second input slot, and I want to project from my current point position. And that is it. Only one thing that I want to do is go up one level, and on the solver, just click on this cogwheel icon, go to Edit Parameter Interface, and then dive back into the solver here, and just drag this advection strength slider over here.
待って待って待って。して、中に入って、よいしょ。
Here, hit apply, accept, and go up one level, and now I've got this advection strength set on my solver directly. And now if I reset the simulation, check real-time toggle, and hit play, we can see those points now wander along the surface. Okay, points are fine. We want lines, however. Let's use the trail node to turn those individual points into lines by not going to preserve original, but connect as a polygon, and then uncheck close rows. And the trail length should be equal to our current playback frame, so $FF. And now we can see we are getting those individual lines that emerge here. And that's the basic setup. Not much. Few lines of vex, bit of advection, few measure nodes. However, it already results in quite intriguing shapes, which I really like. One more thing to keep in mind, or that's maybe worth doing, is creating a width attribute, so we can render this either in Mantra, Redshift, or Octane using the built-in hair primitives. And for that, I'll just drop down a resample node, and in the resample node, I can set my point distance here, the maximum segment length, to something rather small-ish. Let's go with 0.001 in our case, and also let's just drag this down and set the interpolation to subdivision curves to round them out a bit. And here we want to also check curve U attribute, which is just an attribute stored on each point of each individual curve, starting at 0 on the first point of the curves and going to 1 on the last point of each curve. And we can use that in another final point triangle to create a width attribute from this by again first creating an amplitude slider. Let's call this overall scale, create it, let's set it to, I don't know, 0.002 maybe, and then let's create a width attribute, which is a float, and let's use the curve U we just wrote. Let's call this one ramp underscore scale or ramp underscore width. And we're going to use the curve attribute as an input, which is between 0 and 1, and it's a float. And then we multiply it by its overall scale. And that should be a multiplication like this. Again, let's create the other interface element as well. And maybe set up a triangular curve for now like this. Let's go up to our object level, create a...
ラインの太さ、ランプで制御したいだけか。カーブだっけ？カーブ U じゃなかったっけ？あれカーブ U だよね。カーブでいいの？カーブ U だけどな。カーブでいいのかな。カーブ U な気がするけど。 変わるよね。カーブな気がするな、やっぱり。カーブ U な気がする。
A triangular curve for now like this. Let's go up to our object level, create a camera by control clicking in here, make sure it's locked to the viewport. Let's reframe this. Also, in this case, I want to render this using Octane, so I'll just create another 2 tabs, setting one to out and the other one to matte context. And in my Octane tab here, I'll hit render target and Octane, creating an Octane render target here, where I'll set up my rendering that is in the matte context, and a Octane ROP that I can use for storing out images, saving out images in the out context. So in the Octane render target, I want to set this to be path traced. I want to have a texture using HDRI as an environment. In the text environment, I'll set the color space to non-color data and point it to one of my beloved HDRs. And then let's just quickly create another Octane material using the Octane material builder. Let's dive in there, and in this case, I don't know, let's just be old school, use a glossy material, set the diffuse to something really dark, like this, wire up the material like this, set the index of reflection to 1.0, so it's fully glossy, fully reflective, give it a bit of roughness, 0.4, and maybe add an RGB color into the specular, turning the specular slightly orangish, using, I don't know, an H of 20 and a saturation of 0.65 maybe. Let's see how that turns out. Let's just go up one level again, go to the OBJ here, and in our geo assign the material under the render tab here, where I'll just point it to the Octane botnet I just created. And one final thing I want to do before rendering this, in the Octane tab, under the fur tab here, let's check render as curves / fur object. Let's save this, keep our fingers crossed, and hit the IPR here. And after a bit of waiting, we're pretty much seeing nothing. So let's see what went wrong. And of course, in my pointer angle, I looked up the curve U attribute like this. So let's get up again, save this, keep our fingers crossed, and hit IPR again. And at least something is showing up now. It's a bit out of focus, so let's fix that. In the matnet under the render target, in the camera tag, let's uncheck autofocus. Let's also unlock the camera from the viewport and zoom out a bit so we can see the camera. And under the object tab, let's select the camera like this. Make sure the viewport handle is selected and displayed, and hit Z over the viewport to bring up the focus handles. Let's just focus the camera on our sculpture like this and get back into the camera view here and hit IPR one more time. And now we can see we have a rough setup of our bust. So that's it for now. Really quick, really fun one. If you need some 3D scribble-ish sculptures of some geometry, which is mostly working on the edges of the geometry, keeping the overall shape and general form of our sculptures and giving quite a bit of detail. I'll work on this to turn this into an artwork, do a bit of shading and lighting here. And if you are interested in learning more about Houdini, maybe a bit of Unreal or even a bit of Blender, or you just plainly want to support us, consider becoming a patron of ours, as it's with your help that we can keep Intagma running as we do. And if you're already supporting us, thanks so much, with a very special thank you going out to Important Looking Pirates, Jellyfish Pictures, The Mill, Method Studios, Electric Theater, Pixonic, Random 42, Rodeo Effects, Side Effects, Illusion, and Rafik Anadol Studio. Thanks so much, folks. As always, intrigued to see what artwork you cook up using that technique or any other technique, so please don't be shy sharing. And as always, until next time, it is cheers and goodbye.
これはめちゃくちゃ面白かったな。サンプルのこのチュートリアルめっちゃ面白いな。スカイライトにして、ノイズレンダリングするか。マントラでいいや。 線太。何これ。なんでこんな線太いの。おかしいな。イギスはちゃんと入ってるのにな。なんでだろう。ちょっと小さくする。いや、なんか違う気がする。なんか根本的に間違ってる気がする。こんなに細いのに、こんな太く表示されんの。なんかおかしくない？そしてこれワイズの値なの？変だな。本当かな。ちょっと適当に。なんとか割り当ててみるか。いけないとき。まあ、とりあえず、こんなところか。はい。一旦、レンダリングまでやってみました。動画だと、黒点を使っているんですが、黒点は持ってないので、とりあえずマントラで代用しました。これは相当面白いサンプルだったんじゃないかと思います。何でメジャーとかほとんど使ったことないノードだったんですけど、相当使い道が多そうなノードだなというのと、あとこの辺のアトリビュートプロモートで最大値と最小値抜き出してリマップしたときにちゃんと割り当ててるあたりで、オブジェクト変わってもプロシージャルにマックスが変わったりするので、ここは結構こういうのなんか、ここシートで最大値調べてとりあえず入れるかみたいのがやりがちなので、なかなかなるほどと、そうやってディティールを使うんだなというところが勉強になりました。ブラかけるとノーマルが小さくなるから移動量減るんかな。この後試してみるか。あとはこの中のソルバー。 勝利している頂点の近いところを取ってきて、その方向のベクトルを取って、そっちに常にちょっとずつ移動するみたいな感じかなと思います。近かったら、到達したらポジションを入れるってことなのかな。1フレームのシミュレーション0、オブジェクトを入れて取ってきて、で次のフレームからは全部こっちから取ってくるってことなんだ。はい。だいぶ勉強になる回だったなと思います。今日のところはこれで終わりたいと思います。ご視聴ありがとうございました。